Hello everybody, Mr. Hinnon here for the Henstitute. In this edition of the Henstitute, we're going to go over problem number 38 of the horizontal projectile problems. This is the one where it says that a kid takes their toy car and runs it off the end of a dock. So I basically have drawn a picture here where our car is traveling over the end of a dock into the water. I'm going to go bounce through some problems. I just want to kind of make sure I catch all the pieces of it. So in the original problem, it says the child is operating the radio controlled on a dock, accidentally steers it off the edge. So the idea is they're assuming that it's going to be going horizontally. The car's displacement, 1.1 seconds, so we have a time, after leaving the dock has a magnitude of 7 meters. What is the car's speed at the instant it drives off the dock? So since we're assuming that it's going off horizontally, we're really trying to find Vx in this problem. So I want to know what Vx is. So getting back to my picture right here, the time is given to us, this little 1.1 seconds, but here's the part that always messed everybody up. They're talking about that 7 meters, and they say the displacement from where it leaves to where it is, 1.1 seconds, it has a magnitude of 7 meters. Why do they say that? Because the idea is that's a straight line displacement, a straight line distance from start to finish. So this is where it initially was, and this is where it finishes, and that's what we're dealing with. That's not horizontal and it's not vertical, so that doesn't help us out. But if I'm going to try to find Vx, what I really need is I need to know x and I need to know t. Well, I have a t. I really need to go after this by finding an x. Well, here's the cool part. We should be able to actually measure how far over horizontally this thing goes. So I'm going to use my little ruler here and measure horizontally to that spot. So this thing would, if we could, it would travel horizontally all the way to there. Actually, it's going to go a little farther than that. So it'll go all the way to here. That is its horizontal displacement. That's x. We don't know what that is. But this curved line, this little dotted line that I've drawn in here, this is the path that it actually travels because it's going to fall vertically. So I'm going to take my ruler here and let's flip it around so now it's at 90 degrees. Oops. Move it back up here, and so the idea is it's going to fall down some vertical displacement like that. I don't need this anymore, so let's get rid of that ruler. So it's going to have a y on here. What I really want to do is I want to find x in terms of that. Well, I've got the hypotenuse of this triangle, the purple line. I'm trying to find the red line, and I need to find the green. Well, here's the cool part, is we have a great equation for finding y based off of VIY, t, and g. But in this case, just like in all the cases on this set of problems, the VIY is 0, so this part of the equation disappears. So really, I just have to take negative 1/2 times 9.8 times this 1.1 seconds squared, and it should tell me how far this thing has fallen. Yes, it's going to be negative, but that's because it went from here down that distance. So that displacement. So when I take my handy dandy calculator and I calculate all that, I have y. How does that help me? Now I can find x because I know that Pythagorean theorem tells me that 7 squared should equal x squared plus whatever my y squared is. So once I find out what the y is, using this lovely equation over here, I can plug that y value in. Here I can find x, and then last but not least, I can take that x and plug it right in there with my time to find how fast this car must have been going when it went off the cliff. That's a little help with problem number 38, and I hope you enjoyed this edition of the Henstitute.